So welcome listeners. Here we have gathered again in the series on the subject fundamentals of geology, and I'm Dr. Shanti Banerjee, a faculty member in the Department of Geology, Banaras Hindu University, Varanasi. So in this lecture in the series, we'll be talking about the geological time and geological time scale, and there will be two parts of this lecture. So the first part will be talking about a time span of between 4.6 billion years till around 541 million years, and in the second part of the lecture we will talk about the rest of the time till present. So, but before we go into the detailed discussion of time, we will look at the geological time scale overall, and if I simply think in a manner that the overall time span of the evolution of the earth from 4.6 billion years till present, if I summarize that, or if I want to summarize that in a single day clock of 24 hours, then we can also understand the gravity of this timing, that we, the human species, we have evolved at around 11:55 p.m. So, according to that, for only last 2 minutes we are existing in the complete geological time of the earth. So, obviously the geological time scale is a record of life and geological events in the earth's history. So, based on the records and evidences that we find on earth, people have developed the time scale by studying rock layers and fossil records, and also sometimes when they were not available, then people devised the idea of radiometric dating, and based on the idea of radiometric dating, be it using uranium lead dating, be it based on rubidium strontium dating, or on the base of carbon isotope dating, people have commented on the rock records, their timing of formation, and eventually we have fixed it, or we have systematically devised the whole evolution of the earth into a specific geological time scale. So now again, looking at this simple diagram, this clock you can say is starting from 4.6 billion years, which is also, like we have discussed in our earlier lecture when we talked about the formation of the solar system and how our planet earth evolved from the protoplanet to the present planetary state, and so that is around 4.6 billion years. Followed by that, around 4.5 billion years, there was the formation of moon. We will also discuss that how moon has formed over the time, but just to be time specific, so the 4.6 billion years is the initiation of the earth, followed by at around 4.5 to 7 billion years there is formation of moon, and then till you can say around 4 billion years there was a period of meteoritic impact throughout the earth, as we have also discussed during when we have seen or looked into the formation of planetesimal and resulting finally into the formation of the planets, and likewise the other planets as well, where we have distinct evidence of meteorite impacts. Followed by that, you can say at 3.5, early life started at 3.5 billion years, when there is occurrence, or there was occurrence of blue green algae as we know it, and at around 3.5 million years onward also the process of photosynthesis started. At around 2.3 billion years, what happened is atmosphere became rich in the oxygen, and what we call it as the first snowball earth at around 2.3 billion years, and also around near about 750 to 635 million years, and followed by that there was this Cambrian explosion, when there is, you can say, the explosion of early life or origin of early life was dominant after 530 million years, and around, you can say, 380 million years the first vertebrates or land animals evolved. Likewise, around 230 million years the first dinosaur stepped onto the earth, and again and to mention, the first human or the human species evolved in last only 2 million years only. So based on that, the early Earth system till now, and based on the geological record we have, the geological time scale has been divided into certain eons. So looking at the different eons, we have Hadean eon, then Archean, then Proterozoic and Phanerozoic eon. So we'll discuss about each and every eon in detail. But the question is here that why dividing or understanding the geological time is necessary and how it is done. So the answer to the first one, that why the understanding of geological time scale is essential, is first of all, we need to group the time period, the geological time period of similar geological processes and life forms together, and to simplify the vast history of the earth. So that is the main focus of studying geological time scale, because we always try to look into the natural history of the earth, or we try to always constrain the natural history of the earth. So to simplify this vast history of earth into few groups having similar properties, so as to facilitate the study of its natural history. And how it is done? Obviously it is done based on the major changes in the earth's history that are marked by boundaries between different sections, as well as there are different sections which are divided based on the appearance or disappearance, that means extinction of major organisms that have lived on the surface of the earth. Now, naming the geological time, the broad division of geological time can be done into several groups and subgroups. So there are stages of these groups and subgroups. So the broadest group in this is eon, like we have named already: Hadean eon, Archean eon, Proterozoic eon, and so on. And then you have era, like that of in, for example, Phanerozoic eon, you have Paleozoic era, you have Mesozoic era, and also Cenozoic era. And also there are periods. These are relatively subdivisions, smaller subdivision of era. Further subdivision of period gives you epoch. And finally the age, when there is specific age is known of a particular subsection. Now, looking at the presently established geological time scale, so you can see here where it is the first eon, that is the Hadean eon, that we have discussed, that started around 4.6 billion years, and followed by that you have the Archean eon. There are other eras within Archean eon as well: Eoarchean, Paleoarchean, Mesoarchean, and Neoarchean, and again they are grouped or subgrouped based on their age. Then you have the Proterozoic eon. Again, the Proterozoic eon is divided into your different eras: your Paleoproterozoic era, then your Mesoproterozoic era, and Neoproterozoic era. Now, if I look at the next one, that is, so this represents the, you can say, the Hadean, Archean, and Proterozoic eon. They belong to a time collectively known as Precambrian, means anything that happened beyond or before the time of the Cambrian. We will be talking about Cambrian as well. And then after that, whatever has happened since, you can say, 541 million years are all considered under Phanerozoic eon. And likewise, the Phanerozoic eon is being further divided into three eras: your Paleozoic era, Mesozoic era, and Cenozoic era. In Paleozoic era as well, there are subdivisions of periods. So the first period in the Paleozoic era is your Cambrian period, followed by Ordovician, Silurian, Devonian, Carboniferous, and Permian. So after Permian, again you are going now into the Mesozoic era, not eon. We are now talking about a eon, that is Phanerozoic eon, and then subsequently under that you have these three era: Paleozoic, Mesozoic, and Cenozoic. Again, to repeat, your Paleozoic era is composed of your periods of Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian periods. Likewise, your Mesozoic era is also subdivided into 3 periods: Triassic, Jurassic, Cretaceous, and this is the time when the dinosaurs dominated the Earth's surface. And again, finally, the third era within the Phanerozoic eon is divided further into 2 periods broadly. One is Tertiary, another one is your Quaternary. Further subdivision of Tertiary is also available, which are referred to as Paleogene and Neogene. So, we will be looking at this eons, era and periods in greater detail in our rest of the lecture. Now, first to start with the discussion on eons. So, the largest division of geological time, like we have seen, each lasting hundreds of millions or sometimes billions of years, are considered under eons, and broadly there are 4 eons. The first eon is your Hadean eon, then you have the Archean eon, then Proterozoic eon and Phanerozoic eon. So, this 3 eons, Hadean, Archean and Proterozoic, they are also sometimes referred to as the Precambrian eon, and the rest of are referred to as the Phanerozoic eon. So, in case of the Hadean eon, you can also remember, so this is the initiation of the formation of the earth and also followed by the formation of moon and a period of heavy bombardment from the meteoritic impacts. So, the Earth's earliest eon is characterized by intense geological activity and the formation of the planet. Like again, you can relate it with my second lecture when we talked about the evolution of the earth from the protoplanet to the planet. Then it comes your Archean eon, the Archean eon, where life is believed to have originated, the first life originated during the Archean time through the presence of your blue-green algae, sometimes the presence of some stromatolites as well, and it is also marked by the stabilization of earth crust and emergence of ocean. We will be talking in detail about the emergence of the earth and emergence of ocean in, you can say, 2 lectures from now, when we will be dealing with continental drift and plate tectonics later on. And then followed by that you have the Phanerozoic eon. The current eon, which we are presently at the top of that eon, is marked by the presence of complex life forms including plants and animals, and these are further now divided into Paleozoic era, Mesozoic era and Cenozoic era. Now again, if I look specifically into the Hadean eon, which was present between 4.6 to 4 billion years ago. So, obviously, the most important thing is that this time the formation of earth took place. So, your accretion of matter and intense heat was there, like again referring to my second lecture where we discussed about the initial formation of a planet. Then it was followed by the differentiation of the earth layers, from where we have separated protoplanet and planet. It is the same concept. When the differentiation happened, finally it evolved into planet with different layers of stratification, where your heavier or denser elements tried to move towards the core of the planet, and relatively lighter or less dense material, they tried to evolve towards the surface or the upper part of the planet. Then also there was formation of this primordial atmosphere, which was initially devoid of oxygen but was mainly composed of water vapor, carbon dioxide, methane and ammonia, which are obviously the results of early volcanic activity, again that we will discuss in 2 lectures from now in the idea of plate tectonics, when we will be dealing with different tectonic structures on the surface of the earth. So, due to the volcanic activities, again the primordial atmosphere was composed of water vapor, carbon dioxide, methane and ammonia, and like I was mentioning, it was at that time it was devoid of any oxygen. Then what happened around 4.5 if 2 billion years, the formation of moon took place, and it is believed that the moon actually developed due to the giant impact of a planet Theia, which was present between the orbit of Earth and Mars, and it somehow due to the gravitational pull that we have again discussed in our lecture when we talked about the origin of solar system. During that gravitational pull, somehow this Mars sized planet Theia that collided with the Earth at around 4.5 billion years, and finally it resulted into the means you can say ejection of materials and cosmic materials that were still associated with the protoplanet of the Earth. They got separated from the rest of the Earth, and finally they formed the Moon as we know it today. And there was a period, like I was mentioning, between 4.5 to 3.8 billion years. There was huge bombardments of meteorites, or what you can refer to as, like again referring to my second lecture, we discussed about the types of meteorites, and different meteorites fell onto the surface or has plunged onto the surface of the Earth, leading to the first, you can say, the first occurrence of organic molecules in the early Earth, because these comets which are coming or meteorites which are coming from the asteroid belt, like we discussed in the origin of solar system, in the asteroid belt, or they are coming from the Kuiper belt or even the Oort cloud, they carry frozen ice with it, and sometimes some other cosmic materials along with it. So it is believed that the initial organic molecules and water was brought along with the meteorites that has bombarded on the surface on the Earth. Then comes your Archean eon, which is around 4 to 2.5 billion years time span. So in this time, stabilization of Earth crust happened, as we know that the crust, because at this time the differentiation of the from this protoplanet to final planet was complete, as well as the formation of crust was also nearly complete. So stabilization of Earth crust happened, and followed by the origin of the continents. Again, the origin of the continents will discuss in detail 2 lectures from now in the idea of continental drift and plate tectonics, followed by the formation of oceans, as well as what is the most important thing is the emergence of early life. So the initial living organisms were likely in the form of single-celled prokaryotic organisms such as bacteria and archaea, and here also we can see that how these are the early continental crust, these are the early oceanic crust just formed after the differentiation or the main differentiation process within the was completed. Now regarding the origin of early life also, there are 2 major hypotheses. The first one is the origin of life at mid-oceanic ridges, where you have large range of temperature, there is variation of temperature, there is complete absence of ultraviolet rays because they are submerged beneath the sea mostly, and also you have this reducing environment which is extremely suitable for the growth of organic compounds like that of methane. And also there is supply through these large scale ridges, like again this will be discussed in detail when we will be discussing about continental drift and plate tectonics, but just to give you an idea that these are the sites of both volcanism as well as it supplies a lot of sulfur and metal onto the ocean floor bottom. There is another hypothesis, though it is debated or it is not accepted as that of the origin of life at mid-oceanic ridges. Still the other hypothesis is being put forward by Miller and Urey, and that's why this is referred to as Miller and Urey hypothesis. They actually made several organic compounds in lab under thunder and lightning conditions, and they proposed that in the early Earth system or in the early Earth it was full of lightning because the atmosphere was not complete, so it was full of lightning under the presence of the water vapor that was circumferencing the whole Earth. Though this theory is contested, still it is proposed that the origin of life in such condition is possible under the action of lightning. Then comes your Proterozoic eon, when you are dealing with a time between 2.5 billion years to 541 million years. So here you can see the appearance of first eukaryotes. So the oldest eukaryote fossil that have been reported is your algal ribbon, Gypnia at around 2.1 billion years. So the first eukaryote cell might have looked like something like this. Then also parallelly, just after this time, in the Proterozoic eon itself, there was the appearance of multicellular organisms, where we can find Ediacara fauna found in the Ediacara hills of Australia, which are also treated as the oldest fauna on earth. Then you have non-skeletal fossils similar to Nidaria, and there are also some imprints of soft-bodied organisms, and obviously these all organisms, they lived much before the predators. Then finally coming into the Phanerozoic eon, or what we refer to as the, in context of origin of life, we refer to as the Great Cambrian explosion of life, means several life forms, several living organisms evolved during this time. So this is the time between 541 million years to the present. So again, your Phanerozoic eon, like I mentioned earlier as well, is divided into 3 eras broadly: Paleozoic, Mesozoic and Cenozoic, and further these eras are also divided or subdivided into periods. Like the oldest one is the Cambrian period, followed by Ordovician, Silurian, Devonian, Carboniferous, and finally the Permian period. Similarly, the next younger era is your Mesozoic, which is again from older to younger, is divided into Triassic, Jurassic and Cretaceous period. And finally the third one, or the youngest era in the Phanerozoic eon, is your Cenozoic era, which is further divided into 2 periods broadly referred to as Tertiary and Quaternary, and also there is a sub period within Tertiary that are referred to as Paleogene and Neogene. So again, if I look at the geological time scale, again we can again simply summarize that this eons that were existing prior to 541 million years, just prior to the Cambrian explosion, then there are 3 eons: Hadean, Archean and Proterozoic. So if I simply go back to the first diagram, which is mimicking a clock of 24 hours, then again we can see that here between the Hadean eon there was no early life that was present, and at this time the temperature of earth was pretty high. So at that time no life is possible in this environment, as well as there was no atmosphere to live, as well as there was no water like we now see. So the origin of life is out of question here. Then due to the bombardment of several meteorites and comets across the solar system that are coming, be it from the Oort cloud or the Kuiper belt or from the asteroid belt, they are coming with huge amount of water in it and some organic molecules as well present in them. So they first bombarded on the surface of the earth, and from that possibly the first blue-green algae or some algal life developed, and photosynthesis started at around your 3.5 billion years. Then followed by the Archean time. The Archean time, obviously there is still I will not say that there are several life forms that were present in the Archean time, but there is the importance of Archean time, like we have seen in this diagram particularly, that when your earth crust was stabilizing. So the earth crust was again and got divided into your continental crust and oceanic crust. We will have a detailed discussion on continental crust and oceanic crust later on. And in this case you can see this is the ocean floor. Then you have these continents that are also we are living on the continents as well till now, and you have this oceanic crust, followed by that deep within the earth there is mantle. So this differentiation happened at the time of the Archean eon, and again there you have this outer core and inner core as we know today. So there this differentiation was going on at the time of the, you can say, the Archean eon, and obviously the stabilization of the earth crust was going on, and finally the first solid lithosphere formed during the Archean time as well, followed by during the origin of the continents, there are again formation and growth of protocontinents, volcanic activity, sedimentation and other tectonic processes. And during the formation of the ocean, like I have mentioned, due to the high amount of volcanic activities, what happened that gases dominated by water vapor and also associated with carbon dioxide, ammonia, they with time they get condensed, and finally a long span of a few million years continued, a long span of rainfall continued over that time, and finally your oceans evolved over the time. And so coming back to the geological time scale again, so this was the time of Precambrian. Anything that is before Cambrian, that is the time of Hadean eon, Archean eon and Proterozoic eon, and anything whatever happening after Cambrian is again your Phanerozoic eon. So again, to mention your Phanerozoic eon, you have these three eras of Paleozoic era, Mesozoic era and Cenozoic era. And in the Paleozoic era itself, there are periods Cambrian which are further divided into epochs. Similarly, there are periods Ordovician, Silurian, Devonian, Carboniferous and Permian, which are also divided further into a few epochs, and the epochs are generally named on the basis of their age, based on that early Carboniferous, middle Carboniferous, or early Devonian, middle Devonian, late Devonian. Similarly, this is the time of Mesozoic, when the dinosaurs dominated the planet. At that time, Triassic, Jurassic and Cretaceous, these are the periods, and this distinction between the periods, or you can say the eras of Paleozoic, Mesozoic and Cenozoic, they are always marked by either appearance or disappearance, again means extinction, or in broader term we can say mass extinction of living organisms. So these are the you can say these divisions are based on, not on the basis of age only, or not on the basis of time span only. These periods or eras are divided based on the occurrence or non-occurrence, or you can say appearance or extinction of certain group of living organisms, and some of them are pretty distinct. So we will be also discussing about those distinct features in the later part of this lecture. So again, before I finish the first half of this lecture, in Cenozoic also you have these two periods broadly, tertiary and quaternary. Then tertiary is also divided into two sub periods, you can say Paleogene and Neogene, and also now from your tertiary and quaternary period, they are further subdivided into certain epochs. The first epoch was Paleocene, followed by Eocene, Oligocene, Miocene, Pliocene, Listocene, and the present one is the Holocene. So I'll stop here for the first part of the lecture. We will continue with the discussion in the second part of this lecture on geological time scale. Thank you.